This is Algebra 2, Lesson 4-3, Modeling with Quadratic Functions. When you know the vertex and a point on a parabola, you can use vertex form to write the equation of a parabola. If you don't know the vertex, you can use standard form and any 3 points on the parabola to find an equation. So today, we're going to work with how to write equations given some data. No three non-collinear points, no 2 of which are lined vertically, are on the graph of exactly one quadratic function, because a quadratic function doesn't have a straight line. That's why we can't have any of them on the line vertically. So if I wanted to write an equation of a parabola, if I have points, let's say I have a parabola that contains the points 0, -2, -1, 5, and 2, 2. I can write the equation of the parabola in standard form. And then remember, we do know how to transfer from standard form to vertex form. So once you have it in standard form, you could put it in vertex form if you wanted to. All right, so we are going to solve this equation. We're going to figure out how to write the equation of a parabola in standard form, given 3 points. The first thing you're going to do is you're going to substitute the x and y values into the standard form of a quadratic function. Remember, the standard form of a quadratic function is y equals ax squared plus bx plus c. If we're given a point, let's say we have the point 0, -2. Okay. That means that 0 is the x value and -2 is the y value. Okay, so this is my x value and this is my y value. Knowing that, I can substitute in 0 every time I see x into the standard form of a quadratic function, and -2 every time I see y. So this equation, excuse me, in the quadratic function y equals ax squared plus bx plus c, I'm simply going to plug in x and y every chance I get. So y is -2, that equals a times 0 squared plus b times 0 plus c. Well, that means -2 equals c. That was easy because anything times 0 is 0. Same equation, but now we're going to use the point -1, 5. Again, -1 is my x value, and 5 is my y value. So I will have 5 equals a times -1 squared plus b times -1 plus c. So now I have 5 equals -1 squared is 1, 1a plus, oops, going to be minus, 1a minus b plus c, or 5 equals a minus b plus c. Okay. Now I'm going to use the point, what was my third point? 2, 2. So if I use 2, 2, remember again, x is 2, y is 2. So if I plug it into the quadratic equation, I have 2 equals a times 2 squared plus b times 2 plus c. So 2 equals 4a plus 2b plus c. Okay, so I now have 3 equations. Here was my first equation, here was my second equation, and here is my third equation. And I'm just going to write them down here. I now know that my first equation was c equals -2. My second equation was a minus b plus c equals 5. I like them in standard form, so I'm going to write them in the proper order. And my third equation was 4a plus 2b plus c equals 2. Okay, so now I have to solve this system of linear equations. So the easiest thing to do would be to solve it for either A or B or A and B, because I don't want to eliminate C because I already know that C equals -2. So if I took equation number 2 and multiplied it by 2, so I'm going to take this equation and multiply it by 2, I will get 2A minus 2B plus 2C equals 10. And if I take equation number 3, just as it is, I will have 4A plus 2B plus C equals 2. If I add those 2 equations together, I get 6a plus 3c equals 12. So this is equation number 4. Now I can take equation number 4, and now that I know that c equals -2, I can plug back in there and I can solve for a really quickly. So if I take equation number 4 over here, and I know that 6 times a plus 3 times c, but c is -2, has to equal 12. So 6a minus 6 equals 12. 6a equals 18, so a equals 3. I now know that a equals 3. So now I can just plug into equation number 3, and I can solve for equation 2. It doesn't matter. I think I'll look at equation 2. It's a little bit easier. So in equation number 2, I have a is 3 minus b I don't know, plus c is negative 2, and that equals 5. So 3 minus 2 is 1, so negative b plus 1 equals 5, negative b equals 4, so b equals negative 4. So I've now solved. I know that c was equal to negative 2, b is equal to negative 4, and a is equal to 3. So a equals 3, b equals negative 4, and c equals negative 2. So all I need to do now is to substitute those into the standard form of the quadratic function. Y equals ax squared plus bx plus c. So y equals 3x squared minus 4x minus 2, because I just plug in the numbers you get for a, b, and c. And that's how you solve to find a system when you are given 3 points. And you just do that repeatedly, no matter how many different points you get. You can just plug the 3 points in there, make your system of equations, solve your system of equations, and then substitute back in. Now, when more than 3 data points suggest a quadratic function, you can use the quadratic regression feature of your graphing calculator. Right, which means you're going to do the exact same steps that we use with linear regression, except for now you're going to use quadratic regression instead of linear regression. So let's say we have the following points. Right? A soccer player kicks the ball off the top of a building. His friend records the height of the ball at each second. Some of her data appears in the table to the right. What is the quadratic model for these data? And use the model to complete your table. So we have these 3 points. Right? Normally you have more than 3, but if you have 3, it's sufficient enough. You could do this by hand, but why? You might as well stick it in on your graphing calculator. So if you have the 84, you're just going to do the same thing. You're just going to find your matrix. Right? You're going to do a list, so second stat, go to your list, right? Second stat, and you're going to I need to name our list, but I need to put in a list again. So you're gonna hit your stat button, you're gonna edit your list. Okay, remember how to clear your list. You go up to highlight L1, L2, hit enter and clear your list. Okay, and then you're gonna put in for L1, okay, you're gonna put in 0, 1, and 5, and for L2, 112, 192, 192. For the Inspire, you're just gonna create a new document. And you're going to add lists and spreadsheets. Okay, and remember, on mine, so I'm going to put time in. Okay, T-I-M-E for 1. And the second one is going to be height. Okay. And you're just going to stick in the same thing. I'm going to stick in 0, 1, and 5. And then you're going to stick in 112, 192, 192. And once you've done that, you're going to hit your, all right. And once you've done that, you're going to calculate. So if you're doing, if you're going to do for the 84, you're going to hit stat again, you're going to hit calculate, and you're going to go down to quadratic regression, which should be the number 5. For the Inspire, you're going to just hit your menu, and you're going to go to statistics, and you're going to go to start calculations, and you're going to go down to quadratic regression, which is number 6. Okay, and it's going to ask you your X list. For us, it's time, and our Y list, which is height. You're going to let it just take the first one, and then of course you're going to put it down there. And when you go and do your quadratic regression, you should get that you should get the following on your calculator. For those of you on the Inspire, you might actually have to look at your number down at the bottom of the screen because it may have a decimal that's too far out. Okay, what is the quadratic model for these data? So y equals negative 16x squared. Sorry, it's a quadratic function. Negative 16x squared. Okay. Plus 96x. And you scroll down one more time. Plus 112. And you should get the exact same thing on your TI-84. And if you notice here, r squared value is a 1, so this means it's a perfect fit. Because the closer it is to 1, the more accurate it is. It can't get any closer to 1 than being at 1. So this is the correct equation. So once you have that equation, now to easily get into so you can have a table, you just have to graph it. So now you can go and you can graph it. So you enter a new graph. You can just enter your graph as y equals negative 16x squared. Plus 96x. Plus 112. And once you've graphed it, it won't even probably show your entire graph on your thing, but you can put your table up there. You can remember if you hit Control T, you can bring up a table. And notice it brings up your table, so 1 was 192, 2 is now 240. So you can plug that in, 240. 3 is 256. 4 is 240. 5 was 192, which we already knew. 6 is 112. And 7 is 0. Okay, so we should be able to finish that. And it doesn't matter, same thing happens on the 84 if you just graph your equation. Okay, all you have to do is hit y equals and graph your equation. Make sure you don't have any other strange equations in your graph. Okay, so you're just going to put in negative 16x squared plus 96x plus 112. Okay, graph that. Again, it probably won't even show up the whole entire graph on your graph, but you don't really need that. Hit second graph, and that brings you to your table. And you'll notice it's, okay, you can scroll up and down to get all your numbers that you need to fill out your table. Okay? So that's how you use quadratic regression using your graphing calculator, either the 84 or the Inspire. And that's modeling with quadratic functions. It's not a difficult concept, but it is a very important concept.